Given the following functions here at the top, find f compose g of x and its domain, and find g compose f of x and its domain. So the first thing we'll need to do is actually find out what these functions are. So in the first example, I will find f compose g of x. So that will translate over into f of g of x, which will translate over into f of 2 minus x. And that's because of this right here. G of x is equal to 2 minus x, so I'll just replace what's on the inside with 2 minus x. And with this function now, f of 2 minus x, when this x gets replaced, this x gets replaced with the same thing. So this function will equal the square root of 2 minus x plus 5. And we are asked to find the domain of this particular function. So in order to find the domain of this function, f compose g of x, we need to simplify what's on the inside. So this will look like negative x plus 7. So that's from adding this 2 and 5 and leaving the x negative. Then we can set this negative x plus 7 to be bigger than or equal to 0. And when you solve for x, by subtracting 7 and dividing by negative 1, you end up with x is less than or equal to positive 7. And that inequality sign switches directions because we're dividing by a negative number. So we found the domain of the answer. Was there any restriction on the function that we substituted in? So g of x, on the inside function, if you want to think of it like that. Is there a restriction here? And the answer is no. There's no x in the denominator, and there's no x inside of a square root. So this domain was all real numbers. And when we look at the domain of the final function, it tells us x has to be less than or equal to 0. So the domain is all real numbers. X is less, as long as x is less than or equal to 7. I said 0 earlier, I meant 7. And you could also write it like this for interval notation. So we can do the same thing over here on the right. I'm going to stop talking for a few seconds to give you a chance to pause the video and figure it out for yourself. So here is the solution for the entirety of this. And again, when we're finding the actual function, you just have to substitute the function incorrectly into the other function. So you can see the final function here would be 2 minus the square root of x plus 5. And if you find the domain of the final function, you can set the inside of the square root to be bigger than or equal to 0. That leads you to a domain of all real numbers as long as x is greater than or equal to negative 5, or this in terms of interval notation. But also we have to compare this to the domain of the inside function. And the domain of f of x ends up being the same here. So as long as x is greater than or equal to negative 5, everything is good. And back over here on the first example, I want to make sure that you understand that this function inside the box is the f compose g of x function. Find the quotient and remainder if f of x equals this thing and it is divided by this. In order to set this up, we will take whatever is doing the dividing, aka the divisor, and we will set that up outside of a division, and whatever is being divided, or the dividend, will go inside here. But we cannot skip any powers of x. So I see x to the 4th, I see minus 3x cubed, I see plus 2x, and I see minus 5. However, I don't see any x squareds, so we need to insert that into the exercise. So now it's just following a bunch of steps. The first of which is being to divide the first term inside by the first term outside. So here we go. I'm going to take x to the fourth and divide it by x squared, and I'll get an x squared. And I'm going to put this answer right in the top here, above the other x squared. So all of the x squareds will end up in the same column. All of the x to the first powers will end up in the same column. All of the constants will end up in the same column. The same for x to the fourth power and x cubed. So now that we have this x squared here, what do I do with it? Well, I have to multiply it to each term in the divisor. So I'm going to take this and I'm going to multiply it here, here, and here. So x squared times x squared gives me an x to the fourth. Where am I going to put that? Right over here on the inside. Then I have x squared times negative x tells me negative x cubed, and I have an x squared times 1, which gives me a positive x squared. So you can see I'm keeping all of the exponents of x lined up nicely, and that's just an organizational tactic for you to help keep your work organized. So after this multiplication here, you will change all of the signs. So this will become negative x to the fourth, this will become positive x cubed, and this will become minus x squared. And what we will do is we will add all these things together. So x to the fourth minus x to the fourth is 0, and I'm not going to write it here, but it is 0. Negative 3x cubed plus x cubed gives me a negative 2x cubed, and 0x squared minus x squared gives me a minus x squared. You bring everything else down, so plus 2x minus 5, and we repeat the process. So now the first term inside is negative 2x cubed. We are still going to divide by the first term outside, which is still x squared, which gives me a negative 2x. This answer goes back up top. So this is minus 2x. Then yes, you will take this negative 2x and distribute to all three terms here. And when you do, you get this, negative 2x cubed, that's negative 2x times x squared. Positive 2x squared, that's negative 2x times x, negative x. And negative 2x times 1 gives you the negative 2x. Change the signs, so this will be positive now. This one will turn to negative. This one will be positive. And you end up with, here again, a 0. But these other two end up being negative 3x squared plus 4x. And this still comes down, minus 5. And then you repeat the process one more time. So here's the division by the first term inside by the first term outside. You'll put that answer up here, minus 3. Again, all the constants are in the same column. Then you'll distribute the negative 3 to all three terms here, and you'll get this down here. You'll change all the signs. That's minus, that's plus. You'll add things together. The first term always drops to 0. That's the whole point of doing this process right here. The next term is x, and then the last term is minus 2. So now if you tried to do this division again, the first term inside is x, the first term outside is x squared. That leaves you with a 1 over x when you simplify it. And we don't want that. We don't want any x's in the denominator. So the last time you do your division, you get a whole number. That's the last time you will actually be going through to divide the first term inside by the first term outside. The process stops right here. So here is your remainder, x minus 2. The quotient is up here in pink. And if you're asked to write this all as 1, which we are not, you would write x squared minus 2x minus 3 plus x plus, minus 2. So this answer here is what is in the top. This part here is what the remainder is, and you will divide the remainder by the divisor. So x squared minus x plus 1. Find all zeros or roots of the function f of x equals x cubed minus 4x squared plus 3x minus 12. Now I can see this here, that the function in question can be factored by grouping. So I can see this group here and this group here. And so I know out of the first group I can divide each term by an x squared, which turns into a common factor, so that's x squared. And when you actually divide these things here, you'll end up with x minus 4. And in the second group here, I can see that a common factor would be 3. And in fact, it's a positive 3. And when you divide these, you'll get x minus 4. So I'm working on creating a new function that is factored out nicely. All right. So the last step here is to notice that with the 2 terms you have left, you can factor out an x minus 4, and you're left with an x squared plus 3. Cool. So that's it. We can't factor x squared plus 3 nicely anyway, but we can actually set this equal to 0 to find all the zeros or roots of f of x. So x minus 4 will equal 0, and x squared plus 3 will also equal 0. So this left equation is pretty easy. That just tells you x equals 4. But the right one, we have to subtract 3 from both sides and say x squared equals negative 3. And then we can take the square root of both sides, and that'll give you x squared, just x equals plus or minus the square root of negative 3. But you cannot have a negative inside, so the negative will come out in front as an I. So here are the other 2 zeros. Now one thing I want to point out is that with this find all zeros, it doesn't specify find all real zeros. It says find all zeros, so that can include real numbers or rational numbers or whole numbers. And it could also include, if you don't see the word real, anything that's imaginary as well. So here are the zeros for this particular function. Is x plus 4 a factor of f of x? Explain your reasoning. Well, this is a really quick check. All we have to do here is do a quick synthetic division. So if x plus 4 is a potential factor, if we set it equal to 0, we can say that x equals negative 4 is the corresponding root or 0 of this factor over here on the left. So how do we check to see if this is a 0? Well, if we can show this is a 0, then we can show that this is a factor. And we can do this by using synthetic division. So the coefficients of the f of x are 2, 8, negative 3, negative 11, 2, and negative 8. So all I have to do is run a quick synthetic division just to see if this works. This is minus 3, this is 12, this is 1, this is negative 4, this is negative 2, this is 8, this is 0. So over here, since we divided by -4 and got a 0 remainder, that means -4 is a 0 of f of x. And really, we could say x equals -4 is a 0 for f of x, or a root. But to find the factor, we would just have to add 4 to both sides. So this means x plus 4 is a factor of f of x. So yes, the answer is yes. X plus 4 is a factor of f of x. Let f of x equal -3 times the rest of this stuff. Find all the zeros and multiplicities and sketch this graph. So for this one, finding the zeros ends up being relatively easy because you can just take the function, the -3 times x minus 1 squared times x plus 2 squared times x minus 3, set it equal to 0, and solve for x. So really we just need to take each factor here. X minus 1 equals 0, x plus 2 equals 0, x minus 3 equals 0. Well, this means x equals 1, x equals -2, and x equals +3. These are the roots, or zeros, of f of x. And we didn't have to set this -3 equal to 0 because there's no variable being multiplied to -3. Also, if you set -3 equal to 0, you get -3 equals 0. That doesn't make a whole lot of sense. So we just leave the -3 alone. So let's talk about the multiplicities now. So x equals 1 has a multiplicity, x equals -2 also has a multiplicity, x equals 3 also has a multiplicity. And that means how many times would this answer happen? Well, going back to our equation here, this 0, we would get x equals 1 as our 0 2 times. And that's really because we have this exponent 2 on that factor. This would tell us that we would need to have x minus 1 times x minus 1. So if we set each of these two factors equal to 0, we would get the answer 1 2 times. And the same thing happens here for x plus 2. It is squared. So we would have a multiplicity 2 there. But you'll notice over here with x minus 3, there is no exponent. The exponent is understood to be 1. So the multiplicity for this last root is 1. So now we have this graph. And I'm going to put the zeros in the correct order. So I'm going to put -2 here. I'm going to put, let's see, 1 next. And I'm going to put 3 over here. So I can pick some test values. Being, let's pick -3. Let's pick 0. Let's pick 2 and 4. So you can see these zeros split the graph into 4 different intervals. One being -infinity to -2 right here, one being -2 to 1 right here, one being 1 to 3, and the last one being 3 to infinity. I will reference those later, but that's how I was able to pick this number. -3 is in this interval, 0 is in this interval, 2 is in this interval, 4 is in this interval. So I pick these, and I want to find f of -3, I want to find f of 0, and I want to find f of 2, and I want to find f of 4. And what I'm going to do here is use the sign. So I'll get something, but it's either going to be positive or negative. And I just need that sign so I know whether I should be above or below this particular line, which ends up being the x-axis. So let me do a little bit of quick math, and I'll get the answers here for all of these and show you how to sketch this graph.